Are we living in a computer simulation? It sounds like the plot of a science fiction movie. It's a question that some of the world's brightest minds are taking seriously. From tech entrepreneur Elon Musk to renowned astrophysicist Neil deGrasse Tyson. The idea that our reality is nothing more than an incredibly advanced computer program has moved from the fringes of philosophy into mainstream discussion. But what is the actual evidence for this mind-bending theory? Is there any way we could possibly tell if our universe is a base reality or just an elaborate piece of code running on some unimaginably powerful hardware? Let's explore the arguments that suggest our existence might be a digital fabrication. The core of the simulation argument, most famously articulated by philosopher Nick Bostrom, doesn't actually claim we are in a simulation. Instead, it presents a trilemma, a set of three propositions, one of which, he argues, must be true. The first proposition is that civilizations at our current stage of development almost always go extinct before they can develop the technology to create what are called ancestor simulations, highly detailed simulations of their past. If this is true, then no one ever reaches the point of creating universes like ours. So we are likely in a base, non-simulated reality. The second proposition is that advanced civilizations, for some reason, lose all interest in running such simulations. Perhaps there are ethical concerns, or maybe they just have better things to do with their immense computational power than to simulate their ancestors. If this is the case, then again, we are probably not in a simulation. But then there's the third proposition, the one that captures the imagination. If the first two are false, meaning that at least some civilizations do survive to develop this technology and are interested in running simulations, then the conclusion is almost inescapable. Any sufficiently advanced civilization could likely run billions upon billions of ancestor simulations. If that's the case, the number of simulated realities would vastly outnumber the one base reality. Simple probability would then suggest that we are almost certainly living within one of those countless simulations, rather than the single original universe. It's a powerful, logic-based argument that doesn't rely on finding glitches in the matrix. But on a statistical probability, if simulated universes are easy to create for a super-advanced being, then they should be everywhere. But what if there are signs within our own physical laws that point towards a simulated existence? This is where the idea gets even more fascinating. Many physicists have noted eerie parallels between the fundamental laws of our universe and the way a computer program operates. Consider the concept of pixelation. When you zoom in on a digital image far enough, you don't see a smooth, continuous picture. You see the individual pixels, the smallest discrete units that make up the image. There's a concept in physics known as the Planck length, which is an incredibly tiny unit of distance, about 1.6x 10 to 35 meters. It's believed to be the smallest possible meaningful length, the theoretical limit below which the conventional laws of physics and our understanding of space-time break down. Could the Planck length be the pixel of our universe? The fundamental, indivisible unit of space, implying that our reality isn't continuous and infinite, but discrete and finite, just like a digital simulation. If space-time is quantized, meaning it comes in these tiny, indivisible chunks, it behaves more like a computer's memory grid than a smooth, seamless fabric. This would be a way for a simulated universe to conserve processing power by not having to calculate infinite detail at every single point. It sets a limit on the resolution of reality itself. Another compelling piece of evidence comes from a universal speed limit, the speed of light. In our universe, nothing with mass can travel faster than light in a vacuum. This constant, denoted by the letter c, acts as an absolute cosmic speed limit. Why should there be such a limit? In the context of a computer simulation, a universal speed limit makes perfect sense. Think of it as the processing speed of the cosmic computer running our reality. The processor can only compute the interactions and movements of particles so fast. The speed of light, then, could be the maximum rate at which information or causation can be propagated across the simulation's grid. It's the refresh rate of the universe, ensuring the simulation remains stable and consistent. Without this limit, information could travel instantaneously across vast distances, potentially leading to paradoxes and computational chaos that could crash the entire system. The speed of light ensures order and predictability, essential features for any stable program. The world of quantum mechanics also provides some of the most bizarre and simulation-like phenomena. Particles at the quantum level don't seem to have definite properties like position or velocity until they are observed. Before an observation is made, a particle exists in a superposition of all possible states simultaneously, described by a wave of probability. This is famously illustrated by the double-slit experiment. When a stream of particles like electrons is fired at a screen with two slits, and no one is watching which slit they go through, they act like waves and create an interference pattern on the other side. But the moment you place a detector to see which slit each electron goes through, the wave-like behavior collapses. The electrons start acting like discrete particles, and the interference pattern vanishes. It's as if the universe doesn't bother to render a definite reality until it's absolutely forced to by an observation. This is strikingly similar to how video games optimize performance. A game doesn't render the details of a world that the player isn't looking at. It only calculates and displays what's in the player's field of view to save processing power. Could our reality be doing the same thing? Are particles only rendered with definite properties when an observer or a measurement device interacts with them? It's a mind-boggling thought that our conscious observation might be the trigger that collapses a wave of possibilities into a single, concrete outcome. This observer effect suggests that reality is not a fixed objective thing that exists independently of us, but is instead a participatory process, much like interacting with a dynamic program. Furthermore, the very nature of our universe seems to be built on mathematics and information. Physicists and mathematicians have discovered that the laws governing everything from planetary orbits to the behavior of subatomic particles can be described by elegant mathematical equations. It's as if the universe is running on a kind of operating system with its own set of rules and code. Physicist John Wheeler famously coined the phrase, "it from bit," which encapsulates the idea that everything physically every it derives its existence from information or bits. In this view, information is the most fundamental aspect of reality. Particles, forces, and space-time itself are all just outputs of an underlying computational process. If this is true, then the universe is, at its core, a massive information processing system. And what is a computer if not a system designed to process information? The idea that reality is fundamentally digital would elegantly explain why mathematics is such a powerful tool for describing it. The language of the universe might literally be code. Of course, these are all just intriguing parallels, not definitive proof. Critics of the simulation theory argue that we are simply projecting our current technological understanding onto the universe. A few centuries ago, people compared the universe to a clockwork mechanism because that was the pinnacle of their technology. Today we have computers, so we see the universe as a computer. Perhaps in the future, with new technology, we'll have a new metaphor for reality. They also point out that just because a simulated universe would need a speed limit and a minimum resolution, doesn't mean that the existence of these things in our universe proves it's a simulation. These features could just be fundamental properties of a physical, non-simulated reality. Ultimately, we are left in a state of profound uncertainty. We may never be able to definitively prove or disprove that we're living in a simulation. Any evidence we find could itself be part of the simulation, programmed to lead us to certain conclusions or to keep us guessing forever. The creators of the simulation, if they exist, could be so advanced that their methods are entirely beyond our comprehension. But the discussion itself is a valuable one. It pushes the boundaries of physics, philosophy, and our own understanding of what it means to be real. It forces us to question our most basic assumptions about the world around us. Whether our universe is a base reality or a digital copy, it is the only one we know. The laws, the beauty, the mystery, it's all real to us. And exploring these deep questions is part of what makes our existence, simulated or not, so incredibly interesting. Thanks for watching. If you enjoyed this journey into the nature of reality, be sure to subscribe to Space Repo for more deep dives into the mysteries of the cosmos.